Today, let us look at factor theorem and remainder theorem of polynomials. Let us take a number 15 and divide it by 6. Now 15 is called the dividend and 6 is called the divisor. Now let us see what number can we multiply with 6 to get a number close to 15. We see that 6 times 2 would give us 12. Subtracting 12 from 15, we get the number 3. Now 3 is less than the number 6, so we cannot divide 3 by 6. Now the number 2 is known as the quotient and the number 3 is known as the remainder. So we could write 15 equals 6 times 2 plus 3. Or dividend is equal to divisor times quotient plus remainder. Let's take a polynomial 3x square plus x minus 2. Let us divide this by another polynomial x minus 1. So the polynomial 3x square plus x minus 2 is the dividend here and the polynomial x minus 1 is the divisor here. Now let us look at the first term of both the polynomials. What do we need to multiply x with to get the term 3x square? We can multiply it with 3x. So x times 3x would give us 3x square. Similarly, minus 1 times 3x would give us minus 3x. Now let us subtract 3x square minus 3x from the dividend. Upon subtraction, we would change the signs and add the respective terms. So we see that the term 3x square cancels each other out. So we get 4x minus 2. Once again, let us look at the first term of the divisor and the first term of the remainder. What do we need to multiply x with in order to get 4x? It would be 4. So x times 4 gives us 4x. Similarly, minus 1 times 4 gives us minus 4. Now let us subtract 4x minus 4 from 4x minus 2. Since we are subtracting, we would change the signs. So changing the signs, we would get the remainder 2. And we get the quotient as 3x plus 4. So we could write 3x square plus x minus 2 equals x minus 1 times 3x plus 4 plus the remainder 2. Now note that the divisor is x minus 1 and the remainder is 2. Let us write down the polynomial as px. And let us put x equals 1 on both the sides. We get p of 1 is equal to 2. Now note here that the 0 of the divisor x minus 1 is 1. Recall that the 0 of a polynomial is a value of the variable x that makes the value of the polynomial equal to 0. So x equals 1 would reduce x minus 1 to 0. So the 0 of x minus 1 is 1 and we note that p of 1 gives us the remainder. We could generalize p of x as equal to x minus a times the quotient qx plus the remainder r. So looking at the divisor x minus a, if we were to put x equals a on both sides of this equation, we would get p of a equal to r, which means that the 0 of the divisor reduces the polynomial to the remainder. Now pa equals r is also known as the remainder theorem. We put the value of x from the divisor and obtain the remainder. But what if the remainder was 0? Then pa would be equal to 0, which means that x minus a would be a factor of the polynomial px. Now this is known as the factor theorem. So we could write P of x equals x minus a times qx. Now here x minus a would be a factor of px. Similarly, qx or the quotient would also be a factor of the polynomial px, and the remainder would be 0. So the factor theorem tells us that when r equals 0, then we obtain the factors of the polynomial. So the two theorems are related. For a divisor x minus a, if we put x equals a, p of a gives us the remainder. And if this remainder was 0, then x minus a would be a factor of the polynomial px. So let us focus on P of a equals r and look at another polynomial. Now this is a polynomial in degree 4, that is the highest power of x. Now let us see if x minus 1 is a factor of this polynomial px. Now a is equal to 1 here, so let us put x equals 1 and check the remainder. We see that P of 1 is equal to 4, which is non-zero. Hence, x minus 1 is not a factor of the polynomial px. Now let us see if x plus 1 is a factor of the polynomial. Now here a is equal to minus 1. So let us put x equals minus 1 and check the remainder. So we get P of minus 1 equals 0, which means that x plus 1 is a factor of the polynomial px. So we put a value of x to find the remainder, and if the remainder is 0, then we say that the divisor is a factor of the polynomial. Let us look at a few problems. Find the remainder when x cubed plus 3x square plus 3x plus 1 is divided by x plus 1. Now recall the remainder theorem. We simply put x equals a in px to obtain the remainder. Now either you could simply take the value of a and put it in the polynomial, or you could also look at the 0 of the divisor x plus 1, which is minus 1. So let us put this value of x in the polynomial. Both these methods lead us to P of minus 1. It gives us the remainder 0. So the remainder when the given polynomial is divided by x plus 1 is equal to 0. This also means that x plus 1 is a factor of the given polynomial. Let us look at another problem. Check whether 7 plus 3x is a factor of 3x cubed plus 7x. Let us look at the remainder theorem. We are looking at P of a equals r. Once again, you can simply put the value of a, but here the value of a is not so apparent. So let us look at the 0 of the divisor 7 plus 3x. Let us put it equal to 0 and find out the value of x as minus 7 by 3. This value of x reduces 7 plus 3x to 0, hence it is called the 0 of 7 plus 3x. Now let us take this value of x and put it in the polynomial. So we get P of minus 7 by 3 upon solving. The remainder comes as minus 490 divided by 9, which is not equal to 0. This means that 7 plus 3x is not a factor of the given polynomial. Let us look at another problem. Find the value of k if x minus 1 is a factor of the polynomial. Now we are looking at x minus 1 as a factor. For x minus 1 to be a factor of the polynomial, the remainder has to be 0. Recall that this is known as the factor theorem. So let us put px equals 4x cubed plus 3x square minus 4x plus k And since a is equal to 1, let us try to find p of a or p of 1. Alternatively, you could also look at the 0 of the divisor and figure out the value of x as 1. So let us put x equals 1 in the polynomial and put it equal to 0. Solving for k, we get k equals minus 3. This means that for the value of k equals minus 3, x minus 1 would be a factor of the given polynomial.